Problem 20, we've got c equals negative 2d plus 10 and 9c plus 2d equals 6. We're trying to solve for the system of equations. And since we're told what c is, I think I'm going to go ahead and use substitution. So here's my 9. I know what c is. C is negative 2d plus 10. And add 2d equals negative 6. Alright, so we're going to go ahead and distribute now, and I'll get negative 18d plus 9d plus 2d equals minus 6. We're going to combine our like terms here. I'll have a negative 16d. I'm going to subtract the 90 on this side, right? And now I'm going to have that equal to negative 96. And I think that, I got a calculator here, I'm going to use it. I think that 16 goes into 96 evenly. Let me check. It does. It is 6. So D is going to be 6. And now to solve for C, we just plug it in. We substitute the solution now into this problem here. So C equals negative 2 times 6 plus 10. And when we simplify everything, that's going to give us a negative 2. So our solution is negative 2, 6. This is a problem you guys probably could do without my help by now, I hope. But on this lesson, they also want you to indicate whether it's, inconsistent, consistent, independent, consistent, dependent. And so this would be an example of consistent independent. So I'll just put CI. That would be a consistent independent system. In other words, if you graph these, they would intersect at one point on the line. You'd have that solution. Okay. So let's do one more. Here's an example of another problem. 2x plus 4y equals 10, 3x minus y equals 18. Substitution would be one way to go about doing this problem because it wouldn't be too difficult to solve for y. But I think what I want to do is use elimination. So I'm going to multiply everything here by 4 so I can eliminate y over here. So this would give me 12x minus 4y equals, let's see, what's 4 times 18? I think that's 72. I hope I'm right. Okay. And now I'm going to bring this over here. 12x minus 4y equals 72. And because the signs are opposite, I'm going to add together. I'm going to add the equations together. The y's will be eliminated, and I'll get 14x equals 82. Ouch. Okay, so we're going to divide both sides by 14, and I would get x equals 82 over 14. 82 over 14 can be reduced to 41 over 7. Wow, so there's my x. It's going to be 41 over 7, and now the fun part of trying to figure out what y is when x is this unpleasant looking fraction. So I'm going to go back to this equation right here and substitute my solution in. So it'll be 3 times 41 over 7 minus y equals 18, and we're going to try to solve that for y. So 3 times 41, ouch, that is going to be 123 over 7 minus y equals 18, and so we're going to subtract 123 over 7 from both sides. We need to get a common denominator, so that means I need to multiply 18 by 7, and that is 126. So minus y equals 126 over 7 minus 123 over 7. And that's going to give me 3 over 7. But we have to remember that this is negative y, right? So negative y equals 3 over 7, but I need to get positive y, so I multiply both sides by negative 1, and I'll get y is equal to just negative 3 over 7. Alright, so now I've got my ordered pair for my answer, 41 over 7 and negative 3 over 7. And again, this would be an example of a consistent independent system.